Let's start by talking about the latest in security screening technology. What's going on over there?
Okay, well, one of the recent developments is research that's been conducted at the University of Pittsburgh into a new kind of detection system for the checkpoint for passenger screening. It can detect at the individual molecular level. So in other words, at a much, much greater resolution than the technology that's currently available. Now, of course, this is only at the research stage, so a number of other things need to happen before this kind of system can be actually deployed.
So when you think of the staff at airports doing the actual screening, how big a difference would that make if that technology was used?
Well, I suppose they would have to be trained in using those systems, but the main difference would not be so much in the human factor, but in the actual accuracy of the detection of passengers as they walk through the checkpoint.
And when we talk about different threats, you mentioned before we started this chat that there's a new view that also it should be made sure that no explosives are hidden inside the body. What exactly does that mean?
Well, there was a case a few years ago, this wasn't at an airport, but there was a Saudi member of the Saudi royal family who was actually attacked by a suicide bomber who'd hidden an explosive device inside his body. And when that happened, that caused a lot of concern among aviation security professionals because it was a new kind of problem.
That's something the airports and airports safety officials, security officials really need to think about. So
that's right, yes.
The new technology, for example, that you mentioned in the beginning could that potentially help?
Not really, no, because there is a conundrum. There's a problem that faces aviation security when it comes to trying to detect hidden threats under the skin, subcutaneous explosives, in that in order to actually do that, you need a device that's very powerful, a kind of medical standard X-ray device, but that comes with a lot of health risks. And there's a lot of concern among the general public when it comes to actually introducing what is called active X-ray technology, X-ray, transmission X-ray systems, which actually produce and emit a lot of radioactivity and hence could cause health risks if they were deployed routinely for airport security. So most of the systems that we're talking about that are either under development or that are already in use don't actually produce that kind of high level of radioactivity that could detect a threat under the skin.
So what approach exactly should be taken when we think about the threat of, say, medically implanted explosives, say explosive inside breast implants?
Well, I suppose it might actually not be a technological solution. It may end up being more of a focus on intelligence, trying to detect the threat before it actually reaches the airport. And there is a lot of movement now in the industry to what is called risk-based screening, where the normal passenger is subjected to a certain basic level of screening, but thanks to various data that is available to the security agencies in advance of the passenger getting to the airport, the passenger can be sorted into a number of different categories before he or she actually gets to the checkpoint. And therefore, those that are of the highest risk can be identified and screened accordingly.
Can you give me examples of what those different categories are based on?
I don't know, but I'm sure you can guess.
Exactly. Well, moving on to, actually talking about this experience when you go to airports and talking about new technology, is there any hope that in the future that may actually all become easier for the passengers?
Well, that's the idea, and airport authorities and national governments are well aware of the inconvenience of the security process, and that's one of the things that causes the most stress and inconvenience to passengers. So there's a strong business reason for the aviation industry to try and develop a more convenient checkpoint process. However, the threat remains. It can't be minimised, and it mustn't be minimised, and it has to be dealt with somehow.
Let's continue by looking at the European airspace. For several years, the European Commission has co-sponsored a research and development project that's called CESAR. They've been looking into new technologies to improve air traffic control in Europe, and now the work continues.
Correct. Recently, a couple of weeks ago, there was an announcement by the European Commission that extended the mandate for the body which is driving a lot of the new technologies that would be deployed to help run European airspace more efficiently. Now, that body is called the Cesar Joint Undertaking, and it combines the European Commission, it combines airlines, technology developers, and a number of different agencies in a number of different technology development projects that, as I said, ideally would help to make European airspace more efficient in future.
So what can be expected from the future? What could those developments be?
Well, one of them is a way of burning less fuel for aircraft on approach and indeed on the ground as they taxi out towards the runway. Traditionally, aircraft have adopted what is called a stepped approach, where they fly along a certain level for a while, then dip down, then fly along another level for a while, and then dip down, like descending a staircase. There is something called continuous descent approaches, or CDAs, which are designed to adopt a more curved approach, a more regular descent, and that burns less fuel. It produces, therefore, more environmental benefits, and indeed it saves the airlines money.
Exactly, and the research indeed continues. Let's finish this by talking about spaceports and the future of them. There's been quite a lot of excitement about space travel, but there actually aren't that many spaceports around.
That's right. The most advanced spaceport at the moment is the Spaceport America in New Mexico, which is run by Virgin Galactic, a subsidiary of Richard Branson's Virgin Group. And they're the only one that's got a tenant for commercial spaceflight services. And of course, that tenant is Virgin Galactic.
And now there's a new development actually in the US of potentially having a new spaceport.
That's right, yes. Near Houston, there's a dual-use civil military airfield called Ellington Field, which is possibly going to be transformed into a spaceport. The Federal Aviation Administration has the application. It's considering it at the moment. And again, it's a potential development, but there's a lot of talk, a lot of ambition, but not very much achieved so far.
And when it comes to the issue of not really having too many spaceports at the moment, is it because the industry is not really running it and bringing money? Do we actually need to wait for actual commercial human space flight services before there will be more interest for developing these spaceports?
I suppose that can be best summed up as a chicken and egg situation. I think perhaps the idea is a bit ahead of its time. There's lukewarm commitment from rocketry companies, and they would be driving a lot of the business for spaceport operations. It wouldn't only be for human people for space tourism. There would also be a commercial rocketry element to these.